Hello guys, welcome back to the YT University, and in this video we are going to develop a simple application using Python. Actually, this is not yet done, so I'm on the final stages, but the codes are already functional, so I think I can show it to you guys. So I'm going to leave the link to the code in the description box below. So make sure you guys click the subscribe button, hit the notification bell to get updated when I post the final code. So it's an application, so you can download it and install it. And when I'm done and when I pack everything in a simple exe program. Alright, so here this program will not work unless otherwise. We have this library, math, numpy, and then matplotlib, and then pysimple GUI. Alright, so if you're running it with Python in your terminal, make sure that you have all of this. Unless otherwise, it's not gonna work. Alright, so here it's gonna create some Cartesian coordinate plane, and then yeah, that's the program for the making the Cartesian coordinate plane. Gonna show you that later. And then this is the program that makes use of pysimple GUI, where you can input your text. Alright, so this is a user interface, and then here is where we do the calculation. After we get the value, it's some simple algebra that makes use of distance formula, and then so on and so forth. And then we get that, and then we get some values, get the angle, then compute for the vector length here. Then I want to see that on screen, and then I want to see the angle. So it's going to calculate um, everything about the resultant force. So I need this in my science class just to show how vectors are interacting with one another. Okay, that's it. So, and then we're going to plot the vectors on the Cartesian coordinate plane. So let's try that, and then let's click this one. And wait for a while. There you go. So we are going to um, input. All right. So a simple one. Let's say, for example, um, 0 and 2. Okay. So this means that it is along the y-axis. It's parallel to the y-axis, and then here it's let's say 1 and 0. Okay. So when we click submit, okay, there we go. So you see that it's actually not pointing the right way because of the angle system. I think I have to adjust something, but nonetheless it's very functional as of this moment in time. So you can see here, so if I wanted, the angle is 63.4 degrees. Okay, so I think I'm going to adjust some values. Okay, because there are adjustments on how you can make it perfect, I guess. Alright, so the error has to be removed, um, and then make it as accurate as possible. Nonetheless, uh, it's getting better. Okay, and then you can actually print this if you like. Okay, let's just actually it's printable here. You can save this figure as you try to save it, then give it a name. There you go. So that's figure 1, but you can change it. Okay, in yeah. So you can run it again and try it for some other coordinates. Okay, and then print it again. So that's the part where I'm into. I think I need some graphic interface right here, wherein this is the input and this will be the output, and if there's a sine wave there and I want to make some animation, I think I can do that. Like for example, if a boat is traveling in a river, so there is a current flow, water current, and the wind. Okay, it's gonna affect how the boat is going to move on the surface of the water, and I want to show that using this simple application. Okay, so see you guys next time here in the YT University. Thank you.